Hello, everybody. In this part 3 of the alcohol nomenclature session, we will discuss some more example of how to name different type of alcohols. So let's say we have something like this. I'm putting here some random things here, OH. Let's put something like this. So in this case, we will follow the same pattern. So you gotta write down your substituent name plus parent chain. Remember, the parent chain must contain alcohol. So in this case, the OH group here must be connected to the whatever the parent chain you are thinking. So this is a cycloalkane right here. So right now we have a cycloalkanes. So the carbon atom that is connected to OH must be part of the cycloalkanes. So right now, how many carbon atoms we have? We have 1, 2, 3, 4, 5. So we got 5-membered ring. So when you have 5-membered ring, so it's gonna be pentane, but because it's cyclic, we're gonna call it cyclopentane because it's cyclic. Now, what is the rule? The E is gonna be replaced by cyclopentanol. So E would be replaced by OL. So we added cyclo and then we replace E with ol. So that's the part we have taken care of. Now let's look at the substituents. So what are the substituents we have here? So right now we got 2 substituents. So both of the substituents has exactly 1 carbon atom. This is 1 carbon atom. This is 1 carbon atom. So when you have 1 carbon atom, that's a methane, but then ANE is replaced by methyl. Okay, so that's how we name our substituent. So here, so we kind of finalize everything. So now we gotta focus on combining both of them into one name. So I'm gonna call, let's see if it is correct, methyl cyclopentanol. Okay, so let's revisit this. So how many methyl group we have here? So if you see, we have 2 methyl group. So when you have 2 methyl group, you cannot write methyl, that's gonna be a waste of space. So if you have 2, how will we represent 2? We represent 2 as di, 3 as tri, 4 as tetra, and so on. Tetra, penta, hexa, right? So instead of writing methyl, we can write this as dimethyl. Okay, this is not correct yet. I'm getting there. So we're gonna add di to show that we got 2 methyl group. Okay, now let's pay attention to the numbering. How are we gonna number where exactly things are? Well, we can number them. So there is one way to number them. We gotta give the lowest possible number. So because it is a ring, I could start counting here 1, 2, 3, 4, 5. I could start counting here 3, 4, 5. But your goal is to give the lowest possible number to alcohol. Okay, so when you have multiple functional group, then there will be priority takes over. Some functional group will have higher priority than alcohol. So for now, alcohol is the most superior functional group. Alcohol is the most superior functional group. So we'll put that as a high priority. So your goal is to keep the lowest possible number. So this is gonna be 1, always gonna be 1. Now I could name 2, 3, 4, 5, or I could go other way around, anti-clockwise. So obviously we will pick the other way, the clockwise, because if we number this way, we are giving the lowest priority, so the lowest possible number to our methyl substituent. So I'm gonna put 2 comma 2 dash. So 2,2-dimethyl cyclopentanol. We don't need to put 1 there because it's obviously the 1 would be by default. So we wrote the both of the number 2 comma 2 and dimethyl. So let me rewrite this. 2 comma 2 dash, the first letter is capital, dimethyl cyclopentanol. And that is our final answers. All right, so let's do another one. Maybe I will add something like this. I'll add a chlorine right there. Okay, what shall we call it? So our parent chain must contain alcohol. So this is gonna be part of the chain. It has how many carbon atoms? 6 carbon atoms. So we're gonna call it cyclohexane because it is cyclic. That means last E would be replaced by ol, cyclohexanol. Now what is the substituent here? Substituent is a chlorine. So when you have a halogen as a substituent, so halogens are chlorine, bromine, fluorine, iodines. So we write them as chloro. Okay, so we got all the names: chloro, cyclohexanol. Okay, so how about the number? How can we number them? Well, I'll start here 1, 2, 3, 4, 5, and 6, because that's gonna give me the lowest possible number. If I would have gone other way, 2, 3, 4, 5. So 3 versus 5, obviously 3 is smaller. So let's call it 3-chloro. Okay, I'm gonna write them together. 3-chloro cyclohexanol. Right there. That is our final answers. Okay, let's make it a little bit, let's go with the benzene ring. So benzene rings you can write like this, or you can put, instead of writing all those double bond, you can write them as a circle to show the delocalized pi electrons. Okay, so here if we have OH, this has a by default name. So I'm gonna put, oh no, this looks ugly. So this has a by default name. We call it phenol. Everything is written as a phenol derivative. So you start as a phenol. There is no cyclobenzenol or something like that, or benzenol or something like that. Okay, so you start with as a phenol. So phenol becomes your parent. And then you write substituent. So let's say you have something like this, maybe let's say here, chloro. Okay, so what would you call this one? So this one, the parent is phenol. And what is our substituent? Is chloro. And what is the location number? The OH will always get the carbon atom connected to OH always get the first priorities. 2, 3, 4, 5, 6. It in this particular example, it doesn't matter which directions you're going. It's gonna be always the same. So let's call it 4-chloro and phenol. So the final name would be 4-chloro phenol. Okay, let's do one last example, and then I think we can move over from the nomenclature to something better. Okay, so this is a nitro group that is connected right there. Okay, let's make it a little bit more challenging here. So there is a nitro group that is connected there. So we follow the similar pattern, substituent plus parent. So parent is phenol here. Now we got two substituents. Substituent 1 is chloro. Substituent 2 is nitro. And obviously we have to write them alphabetically. So chloro will go first, nitro will go second. Now let's look at the numbering system. Now this one might get tricky. I'm not sure. So let's see. This is always 1. So this is always 1. So let's go clockwise. 2, 3, 4, 5, 6. So if I go clockwise, my substituents are in carbon atom 3 and 4. So clockwise, my substituents are 2 and 4. All right, so clockwise. If I go anti-clockwise, where are my substituents would be 1, 2, 3, 4, and 5. So my substituents would be on number 4 and 5. So pick the lowest of all. So in this case, the lowest number 2 versus 4 is 2, and the lowest number here is 4 versus 5. Then lowest of these two are 2. So you go with this particular numbers here. So the correct answer is this one, not the one in the bottom. So based on this conventions, our chloro location is 3, nitro location is 4. So let's combine all of them. 3 chloro, 4 nitro, phenol. Okay, there is ortho, para. Okay, I should put ortho, meta, and para nomenclature as well. Is written as OMP. Instead of putting number, you might see sometimes later we will discuss when we study the benzene ring. When we study the benzene ring, you will know a little bit more about ortho, meta, and para. Okay, my meta looks ugly. So if you have a phenol here, the carbon atom that is right next to the phenol are called ortho. The carbon atom that is next to the ortho this is meta locations. And the last one is here. This is para. So the one that is opposite, that is called para. The one that is right next to the phenol called ortho. So there is another way to write this. So maybe I will give you one example and I'll finish the video. So in this case, the parent is still phenol. The substituent is chloro. Now we can call it 1, 2, 3, 4, 5, 6. So we can call it 2-chlorophenol. Or, so what is the locations we call it? The one that is right next to on either side, that's gonna be called as orthochlorophenol. Or we can call it 2-chlorophenol. All right, that's all I had for your phenol chapters. Okay, we will know some of the basic nomenclatures. That's all I had to say. We'll move on to the new topics.